That was good. I like that. Can I steal that? Can I use that? No, because like I can use that one. Like that's quality. Nah, bro. I can't even eat a pancake in peace. So like the no, that's I like it. I like it. Go ahead, finish. Sorry. Not at all.
She said, and I quote, I don't know if I should be either disgusted or interested. Like, it's a pancake. He's not coming after your bill. The man respectfully doesn't even know you.
So wait, you're talking about this happening in middle school?
Yes. I kid you not.
I gotta tell you, like what people say in high school to each other is like crazy. What people say in middle school to each other, no, it's like insane. It's like on another planet. It doesn't even mean anything. It's like it doesn't, like people tell me what happened to them. Like I have these kids in high school and stuff like that, and they're like, "Oh, I'm dating this person, I'm dating that person." I'm like, yo, it doesn't matter. Like, it doesn't matter. You're not, nothing's gonna happen. Like, the chances of you actually marrying this person or anything like that is like zero. So like and then my daughter is still dating the person that she married, that she was dating in high school. But the I wouldn't worry. Like I gotta tell you, like one of the most important things is not looking about what happened before. Just try and figure out what you need to do in the future. You know what I mean? And it's easier said than done, let's just say. Okay. But that's what you gotta try to do, everybody. So like all right, allow, sit Lolly, Rachel, Melanie, Christina, Joel, Marissa Bull, Cheval, Franklin, Lucas, Sangovia, Jaden, Annalise, Zane, Indira, Kamani, Chloe. All righty then. All right, so you do have your exam and stuff that you have to complete. Like it's due Thursday, I think, or something. Okay. Yeah. I don't know when it's due. Thursday or Wednesday. It's either due tomorrow or the next day. But it's due, yeah. So I said that we were gonna do some more examples with this base theorem stuff. Is that correct? All right, so let's do that. Then we will move on to the next chapter. Also, I did say that, so this exam, I made it just on chapter 4. Exam 3 will be on chapters 1 through 5. Does that understand what I'm saying? All right. All right, conditional probability. So we talked about this before. Probability of B given A. So if we have like A and B here, B given A, so that means A means really we're just only in this part here. You say given A occurred, right? And then the probability that B would happen is that region out of that yellow region. Okay. So this is A and B there. And then this is A. All right, so we talked about the prior and posterior probabilities before. Is that correct? Does everyone remember that? The prior was the probability that you get before something was going on. The posterior probability was like based off of some sort of additional updated information, what the probability would be after you kind of got the additional information. Post. Does that make sense? We did this example with this cigar thing before, right? All right, so let's do another one. Oh, see, I should have just waited for this. So I don't know if you recall the question from before, but they had like I kind of agree with this because this is how I used to do it when I was in school. So it says like this one we calculated it. And I tried to draw this picture over here. I don't know. Do you recall this picture? Do you remember this? So then what we were saying was is that, or I was trying to say, I should say, 51% of the people were male, 49% of the people were not male. Is that correct? Right? And then they were saying, oh, there was this interview and the person in the interview was smoking a cigar. Is that correct? Right? And then they started saying, like, given this information, they were asking what was the chances it was a male. Right? Do you remember the question? All right. So then they had said something like the probability of having a male in general was 51%. The probability of not having a male then was 49%. The probability of smoking a cigar, given the fact you're a male, is 0.095%. The probability of smoking a cigar, given the fact that you were not a male, they said was 0.017, I think. Yeah. Does that make sense? So then, given the fact the person was a cigar smoker, what are the chances now it was a male? That's what they asked. Okay. Does anybody remember how to calculate this first? Yeah, but if I have to know a formula, then I'm probably not gonna be able to do it, to be honest. If I have to use the formula, I'm probably not gonna be able to. That's correct. So, given the person is cigar smoking, what's the probability? So, first, it's helpful just to write these things down, like with the actual notation, because it sort of starts helping you to remember what it is. That's why people write some of these things this way. So the probability that it's going to be a male, given the fact it was a cigar smoker, right? Now, like, what does that mean? That means like there's a bunch of cigar smokers, and some of them are males, and some of them are females. Is that correct? Right? And this thing here means first, so you have to just remember these definitions, but you need to know this definition, otherwise you don't know what conditional probability means, because this is the definition. So the probability of A given B is the probability of A and B divided by the probability of B. And again, that really just came from saying that, like, if you have A and B, you need A to happen, then you need B to happen given A. So if I just solve for this, you would end up getting what? I could divide both sides by P of A. And then you would get P of B given A equals 2. These two would cancel. You would get P of A and B divided by P of P. Sorry, A. All right. And so these two formulas are really the same formula. We're just switching what A and B mean. Does that make sense? All right. But the point is like this is just coming from saying the and thing. Does that make sense? You gotta, if you say A and B, you gotta make A happen, then B given A just happened. Does that make sense? All right, so this would mean what? What do I write on the bottom here? What do I write on the top using this formula? The top is going to be cigars and males. Try and write them sort of like in the same order. Does that make sense? Again, it just helps a little bit to remember. Does that make sense? All right, then what? Over cigar smokers, because cigar smokers is the total. Does that make sense? Good. Okay. Does that make sense? All right. Then the thing is though that like we just said though, like these are the cigar smokers. Is that correct? Oh, sorry. I didn't want to call these females. I'm sorry. I called these not males. Right? All right. So then this says males and cigar smokers. Right? Then we have the cigar smokers, but if we're gonna add up all the cigar smokers, we gotta add up like how many are from here and how many from there. Does that make sense? So then it's like males and cigar smokers plus not males and cigar smokers. Does that make sense? Does that make sense, guys? All right, and then all I'm gonna do now is really use this thing here now. Does that make sense? If you say A and B, you want A to happen, then B given A or something like that. Does that make sense? Because that's how you calculate these, and you already have to know how to do that from the other sections or whatever. Does that make sense? You understand? All right, so how do you calculate this? It's going to be what? You have to have a male, then you have to have a cigar smoker, given the fact it was a male. Or on the bottom, this is really going to be the exact same thing because it's the same stuff we wrote on the top, right? And then this is different, I guess, but first now it's going to say we need it to be not a male, and then we need a cigar smoker given the fact it was not a male. Does that make sense? And then we just use the numbers. So then it's the chances that it's a male is 51%. The chances that it was a cigar smoker given that it was a male is this. So that's 0.095. Then this is 0.51 times 0.095 plus 0.49 times 0.017. And then we said that this number ended up being approximately like 85%, I believe. So just by getting the additional information of knowing that the person was a cigar smoker, we ended up being able to change our answer from 51% to 85% chances that it was going to be a male. Does that make sense? Question, Indira? Does it make sense, guys? All right, I want to do another one now. Because I didn't really want to just do the same thing. All right. Oh, I was drawing this picture also, because this was kind of like the whole picture more so. So like 51% of the people are males, 49% are females. Is that correct? Then out of those 59%, like 9.5% of like this total from here to here, right? Is cigar smokers, and then this is like, I was trying to say this is like 0.017 of like that. Does that make sense? Does that make sense? So then if they say to you, what's the probability that you're a male given you're a cigar smoker? It's like the cigar smokers is like this yellow part, and then the male cigar smokers is the blue part. Does that make sense? So it's like 85% or whatever. Does that make sense? Question with this? So then he starts saying this. This is like, I think when I used to get confused when I was a kid, like this is exactly what I used to do. All right. Now, I was younger than you. All right. I think you can do this just fine because you need to know how to multiply. Does that make sense? And the reason why I say that is if you read these numbers here, this stuff should make a heck of a lot of sense. Because if I start saying that this now, not really the way this is written right here, because the way we were writing it before makes a lot of sense. Males and cigar smokers, males and cigar smokers plus not males and cigar smokers. Okay. So why do I think this makes a lot of sense? Well, because if you just think about it with multiplication, it really does. All right. So if you want to be a male and a cigar smoker, right? Then like there's these males, however many of them, right? And then some like fraction of them are the cigar smokers. Is that correct? Right? So that's what this is going to do. It's like, oh, males and cigar smokers. Well, we need them to be a male for sure, right? And then we also need them to be a cigar smoker given they're a male. Okay, what does this mean now? So the probability of male is 51%. The probability of cigar smoker given male was 9.5%. Okay, so 51% of the time they're a man. Is that correct? All right. But 9.5% of those times, right? And of just means multiply. Is that correct? Does that make sense? So it's like 9.5% of the 51%. Is that right? Does that make sense? That's the conditional probability part. Does that make sense what I'm saying? So then it's like 51% times 9.5%, right? Does that make sense, guys? All right, well, what's another way we could think about this? Start making up numbers. We have to know what numbers to make up. What numbers would you start making up if somebody said something was 51% and you wanted to try to imagine what it meant? I mean, like, I have to start, I just want to know what numbers would you start coming up with to make up some sort of situation where this would make the most sense to you. If someone started saying men were 51% or something. It would be 49%, that's true, or not males. But but I mean, I want numbers. I don't want to use percentages. No, 51, first of all. 51 over 100. What do you mean? That's just a fraction now. I mean, but I want to say something with like actual like things. We're counting and stuff like that. I want to think about it with the sample space. Pretty much. That's pretty much that's exactly what I'm talking about. So like I imagine then some sort of like sample space here, right? And then, we have these M's or whatever. Let's say there's, 40 of those. Does that make sense? 50, right? And then there's this one more. Does that make sense? And then over here, there's these not males. And then there's a few more. Does that make sense? And then it says 9.5% of those people. Does that make sense? So then we don't really need to write it out like this. We can just make a table, really. Does that make sense? And then the males were saying, I guess there's 51 and then there's 49, so that we have a hundo. Is that correct? And then don't tell me you can't sit there and tell me what this means then. Does that make sense? Because all you have to do is remember the percent of means multiply. Does that make sense? Because if you know what this number means in the question, which means you just read it, right? Then you start saying that this means 9.5% of the males. Is that correct? Smoke cigars. Does that make sense? So then we have the males here. Is that correct? Does that make sense? So then we should be able to say then how many people smoke cigars. Should be 51 times 0.095. Is that correct? Does that make sense? Does that make sense? And then this should be what? 49 times 0.017. Is that right? So I don't know. It's not honestly. You should be able to tell me this. Does that make sense what I'm saying? Does that make sense? Like there's no way I believe someone when they sit there and tell me that they actually can't do this. Am I gonna if it's easy? No. But but I don't know. I think the person. Does that make sense? So then so then this means now it's like, all right, well, instead before I was saying 0.51 and 0.49. They were just writing as percentages. Does that make sense? We could just move the decimal 2 places over if we wanted to, and then we'll give you the same answers we were having before. But honestly, it makes no difference because if I multiply numerator and denominator by the same number, it's not going to make any difference. So if I just wanted to write now and use this, 4.845 divided by 4.845 plus 0.83333, whatever. Who I multiplied wrong? Something just went wrong. 1 second. This thing's not multiplying correctly or something. 4.845, 4.845. That might just do it. There you go. Okay. So then this is the same, more or less the same answer we just got before. Does that make sense? Does everybody see that? The only reason why I'm not getting the exact same answer is because I rounded stuff. Okay. If I don't round it, I'll get the same answer. Does that understand? Because if you but I wouldn't do it this way. You should be able to tell me how to do it this way. Because if you say 51% of the people are men, then 9.5% of those people are the cigar smokers who are men. Does that make sense? Does that make sense? And that's all we're doing here. Does everybody get it? All right, let's do another one. Oh, so that's what Buddy's doing here. He's like, assume some convenient value for the total number of items involved and then construct a table. So like, I like what he's doing here because he's saying it's a big enough number and then you're going to get all numbers everywhere. Does that make sense? Integers, excuse me, whole numbers. All right. So then this, like, what is he saying? He's like, oh, there's 100,000 people, there's 51,000 men, 49,000 females. Is that correct? Then 9.5% of these would be here. Is that correct? Etc. Does that make sense? Same thing, right? But you should be able to say it also just in terms of percentages. Is that correct? Does that make sense, guys? Any question with this? But again, if you try to write out a sample space, right, it will make it easier. Does everybody understand what I'm saying? Where there were more problems. Oh yeah, they were over here. Alrighty, what does Buddy have for us? I'm gonna pick a bad one, whatever the worst one is. Extending Bayes theorem. Yeah, whatever. It's not that hard. It's the same thing. You shouldn't have honestly have an issue with this. But why he doesn't have anything that hard here? All right, I think I have another one over here then. Yeah, this one should probably be better. All right, 2.1% of the people are infected with a certain disease. There's a test for the disease. However, the test is not completely accurate. 94.6% of those people who have the disease test positive. However, 3.3% of the people who do not have the disease also test positive. A person is randomly selected and tested for the disease. What is the probability that the person has the disease given that their test result is positive? Does everyone understand? Anything they tell you in the question is a fact, unless they say otherwise. Because that's the only thing you have to go by. Well, 2.1, no, they did not say the test results indicate that after taking the test, 2.1% of the people ended up showing positive. Does that make sense? This is saying 2.1% of the people in the population have the disease. That's it. Like for real. Does that make sense? Like you get what I mean by that? I mean, it's a good question what you're asking, but you have to be able to read that there. Does that make sense? But that's exactly what you need to ask yourself. Okay. So like but 2.1% of the people have the disease. So it's important to go and start like labeling them. Does that make sense? So like you just did that's exactly what you were trying to do pretty much. So I would just go like that. Does that make sense? But then automatically, you remember the author was trying to insult us before? Do you remember that? He was saying, "Oh, but you're an idiot if you can't realize what the percentage of people that won't have the disease is." What he was really trying to say is always think about the complement. Does that make sense? Does that make sense? So what would the complement of this be? Yeah, what would that so what would be if they tell me this, what's the probability that someone doesn't have the disease? 97.9 is correct. Does that make sense? No, I'm just saying, like, that's one of the things that's helpful when doing this problem. That he says that one part is easy and everybody should realize, but I'm telling you right now that one part is actually one of the parts that's the hardest to remember to do with this whole thing. Okay. Once you do that, then the rest of it, as long as you know all this other stuff we were doing from before, it should be fairly easy. All right, there's a test for the disease, blah, blah, blah. It says this stuff. Now what do I do? No, that doesn't say 94% of the people who take the test are positive. Nobody can tell me what to do? Only reason why I'm saying this is that you're gonna have to do this on your tests, and you're definitely gonna have to do this when you take your final. And I'm just telling people, like, you cannot expect to be using all of these resources and stuff like that when you are taking the exams and then expect to do well in the final. Does that understand what I'm saying? But if you do the homework and you just try and answer this stuff without, looking at the answers and stuff, then you'll be fine. This is definitely on the homework. So, what do we do? I mean, I should continue to label stuff at least. What does this mean? This number here? How do I label it? Nope. That's not what it says. Nope. What does it say right here? Read it out loud. 94.6. Somebody read it out loud. So what does that mean? That means that's just 94.6% of the people test positive. That's what that means? Who have the disease. So what does that mean? In terms of how do I write that?
That means that 5, 3, 4% got a false
False negative.
false negative.
But still, what does this mean? I gotta write it with this type of stuff. How do I write it? Go ahead, anybody? Probability of what? Probability of, you said D, you said? Uh, this is saying 94.6 test positive. Is that correct? So they're getting a positive. Is that right? 94.6 of those who have the disease. Given you had the disease, that's when you're testing positive. Does that make sense? Not the probability of disease given you're positive. Now, again, you do these backwards, though. That means you can't read the question. Does that make sense? Does that make sense? Mm-hmm. Right? Does that make sense? That's correct, though. Okay? But you need to be able to read this, though. Does that make sense? But all we're asking, though, is what is given, really. Does that make sense? You just got to ask yourself, which part are they saying is given? What's the total? Does that make sense? So they're saying 94.6% of those who have the disease. All right, it's out of the disease people. Does that make sense? Question with that? All right, what's the next one here? 3.3%. How would I write that one? But I sincerely believe that you go through these problems and you understand this correctly, and you should be able to tell me that the rest of it should be fairly straightforward, because you have to know how to do the rest of it when you're doing this. Does that make sense? Say it one more time. T, what do you mean T? Yep. Positive is correct. Given, what'd you say? Not D is correct. Definitely right. All right. Does that make sense? Good. All right. What else should I write out to help me answer the question? Well, I would write out what the damn question is. What the hell are they asking me for? Like, you have to start there. Does that make sense? Does that make sense? So what are they asking me for? And I need to be able to write it using the notation. Does that make sense? Because if I do, then I can use the formulas. Does that make sense? If I don't, I have to really think it all the way through every single time. Does that make sense? Which is fine. You should a little bit because you got to make sure you're calculating something correctly, but certainly easier if you follow the same framework. Does that make sense? Instead of rethinking it all through each time. Does that make sense? All right. So what do I write now? What are they asking me for? Probability of, what are they saying? What is the probability that the person has a, nope. Look, it says it right here. Yeah. I mean, it says, this says, this I told you means given. Is that correct? So if they write that there, that should be easy. Does that make sense? The other one, you start telling me when they have numbers and stuff like that, that's a little, when they say this here, like this, that's literally the same thing as definition. Because we wrote previously like P of A given B or whatever. We wrote that means like A slash B. We said that means A given B. Does that make sense? So then, all right, I said that line means given, like in math all the time. All right. Or such that, or when, or whatever. Okay. Well, we said that also. That does it mean the same thing if I say probability of D given positive or positive given D? Do they mean the same thing? Then you don't know what it means. Think about it. Seriously. The chances that you're diseased given you tested positive, is that the same thing as saying the chances that you got a positive result given you had the disease? It's not the same people. Does that make sense what I'm saying? This is people who were tested positive. And we're asking if they have a disease. Does that make sense? If I switch these two, then it's people who have the disease and whether or not they tested positive. Does that make sense? It's not the same thing. Is that correct? We said it before also with what's the chances given you're a girl, you're gonna pass the test? What's the chances given you pass the test, you're a girl? I mean, this is not the same thing. Does that make sense what I'm saying? But like it's just not the same people, really. Does that make sense what I'm saying? You know what I mean? If you're looking at positive first and then disease, you're looking at out of all the people who have the disease, they all take the test, right? Which ones out of those people have positives? But that's out of the people that had the disease. Okay. Now, if we do it the other way, right? Well, that we were just counting for those. Does that make sense? This now, if we do it the other way, though, which I guess is this, right? Out of all of the people who tested positive, like it's not even the same group as before. Who out of those people had the disease? It's not the same people. Does that make sense? All right, what do I do though? How do I do this? Still nobody? What should I do? I mean, I always just think about number divided by total. So can you tell me what the total is and can you tell me what the number is? What is the total supposed to be first? Total is what? Total of what? What'd you say? Nope. I'm talking about, I just want to know in words what it means first. Like, this is just a question. That's correct. But let's first just start by just saying that's correct. Okay. But let's first start saying just positives. We were said before, right? If you say given, I've said this a bunch of times, right? Given the positives, that's out of all of the positives. Is that correct? So the positives are the total. Is that right? Does that make sense? That's helpful to remember. So you understand what I'm saying? Because that's what we call the reduced sample space stuff from before. Remember all right? So positives are on the bottom. What goes on the top first? Not just disease people though, because the disease people that would be even people that had negatives. Does that make sense? It's the probability that they had not given. That's what this says right here. And they were positive. Out of the positive people, we want to know the chances you had the disease, right? That means they had to have the disease and they were positive out of those people. Is that correct? Does that make sense, guys? Yes? But number divided by total. Does that make sense? All right, now what? Now, anytime if you want to tell me how to calculate it, you can tell me that also. We don't have to keep writing out the formulas. Nope. Nope. Close. Nope. No. Remember, we had to add something down here. Is that correct? Right? Why? What do we have to add down there? Because I always said you have to think about the total first. Is that correct? So how do we think about the total here? How are we going to get these things? But you got to watch. Okay, so like this is probably the first time you're probably thinking about this stuff. But I said it before, but it's hard to realize until you do the questions. Honestly, you cannot confuse what and given means. Does that make sense? It's very easy to do that. It's they almost sound the same. Does that make sense? What I'm saying? That's the problem. You know what I mean? And like if someone tells you they don't get confused with this stuff, they're lying. All right. But that's why you're learning it. Does that make sense? So you don't make that type of error. All right. But you cannot think that given and are the same thing. Long time no see. So then but you cannot think that given and are the same thing. Does that make sense? Because the chances that I pass the test and I'm a girl, that's just out of everybody. Does that make sense? That's just asking for how many people are girls who pass the test out of everybody. Does that make sense? If I say the chances that you pass the test, given you're a girl, though, now we're just asking the people that pass the test out of just the girls. Does that make sense? And still is out of the total. Is that correct? So what this formula starts doing is really just referencing things from the total. Does that make sense? As opposed to saying the reduced thing. All right. So where can we get people that are positive? How do we determine who's going to be positive? See what I'm saying? Nope. Because these two numbers, if we look at the last example we were doing, I think we could do this one too. Whatever. Actually, I should have just done on that one. Sorry. All right, so here, this would be then saying like, the complement of this is what? The chances that they're gonna be not positive given they had the disease. That's 0.054. And then the probability that they are not positive given the fact they did not have the disease, that's going to be 967. So these are the not positives, right? According to what you were just saying, if I add this up, I'm going to get over 100%, right? That can't be correct. You understand what I'm saying? So that also, if you add this up, you'd be telling me that what, 98% of the people, give or take, is getting positive? That's not right. Does that make sense? That makes no sense in terms of the question. Does that make sense? But you got to ask yourself those. I mean, you know, but that's not. But this, what does this mean, and what does this mean? This is the chances that you're positive given the fact you had a disease. Chance you're positive given the fact you didn't have the disease. It's not the overall chances. I can't just add those two things together. Does that make sense? You get what I mean? But you get what I'm saying with these adding the numbers also? Like, there's no way that the chances that people were positive was going to be 98%. That would be the craziest test that's ever existed. 2.1% of the people have disease. 98% of the people start testing positive. Who's buying this shit? Does that make sense? All right. No, but you get what I mean? You say this crap because then you're like, does it make any sense? You know what I mean? And then you'll be like, maybe, maybe not. Right? All right. What do I do? And why am I adding here? Still nobody's answered that question. How am I going to break up these positives? Because it didn't tell me how many people are positive. Is that correct? So how am I going to figure out where the positives are coming from? Where could they come from? People already said it actually before. But I think you said given it, and then I started going ranting and saying all kinds of shit. Where can we get the positives? What would you say? And again, the only thing you can do is read the question. Just keep reading it, and then you think about it, and you'll be like, oh, if I had to get the positives and figure out where they're coming from, for what? I just want to know who is positive first. That's all I want to know. If you can tell me that, then you'll tell me you understand. If you can't tell me that part, there's no way you understand. Where are we going to get the people who are positive? Try and draw a picture and tell me where they're coming from. Like the same types of pictures we were drawing with like the rectangle. Does that make sense? Does that make sense, guys? Or what he was doing before he was writing out this type of deal. Does that make sense? You don't have to necessarily do it with these with like big numbers or anything like that, but just even with the boxes is usually enough. Does that make sense? Figure out, tell me which boxes are important. Does that make sense? Don't even have to fill them in, right? Because if you can do that, usually that'll be enough to sit there and start being able to figure out how to do it. Oh no, it does. We need that. We need all this crap they're saying here. But I'm just saying how we're going to use it. But I'm saying just in general, this question says the probability of D given positive, right? The chances that the person has a disease given the fact they tested positive, right? So we're saying this is the probability that it's going to be the person has a disease and they were positive divided by the chances that they were actually positive. What I'm saying is that this one actually is fairly easy to calculate. But if you don't understand what the bottom part means, it's going to be a little bit difficult. So how am I going to determine what what the chances are overall that you would actually be positive. And where would the people who are testing positive come from in terms of how they broke the population up here? Does that make sense? Where could you get positives? You could be what and get positives. You could be what else and get positives, etc. Where can people get positives? They say the words in the question. No. Rarely ever were we going to subtract probabilities, except for when we do or. But I'm just saying, I'm not asking you to give me numbers. I'm just asking in words. Where are the positives coming from? Who could be positive here? They could be positive and have the disease, right? Or they don't have the disease. That's correct. That's it. They broke up the population into people having the disease and not having the disease. Is that correct? So either the person was positive and they came from having the disease, or the person was positive and they didn't have the disease. Is that correct? That's 100% correct what you were saying. All right. So how do I write that? Nope. The probability that they have the disease and they're positive, they have to be positive, right? I can't just add up all the people who have the disease. Does that make sense? That's correct. Because again, all I'm really thinking of is that there's these people with the disease. Some of them are positive, some of them are not. Does that make sense? Does that make sense? Oh, wait, sorry, I did it wrong. Positive. Some of them have the disease, some of them don't. Does that make sense? Does that make sense? Nope. Because these are not the same. Given and are not the same. Does that make sense? Do you understand? Well, the top really just stays the same. Now you should also be able to tell me that it makes sense that this and this are both the same here. Is that correct? All right. What do I write for the numbers now? No, no. The top's not right. Go ahead. You say so? That's correct. So this first you need to have the disease. So that's 0.021. Then you need to be positive, but given you have disease, so positive giving you a disease, right? 94.6% of the 2.1% of the people. Does that make sense? Does that make sense? Try and use the of thing. That's really all this is saying. Does that make sense? All right. Then the bottom, well, this would have to be the exact same thing, I guess. Good. What else? Well, there's going to be a 0.033 is correct, but I need, what else do I have here? 0.979 is correct. They need to not have the disease now, and then they're going to be positive. Does that make sense? So like these are the total percentage of these people in the entire population. These are the total percentage of these people in the entire population. Does that make sense? Does that make sense? Let's just write out the numbers. You should be thinking about this stuff. Then you'll remember how to do it. If you don't, And you just start looking at these formulas. Honestly, a person's not gonna be able to do it. 0.019866, whatever. 0.019866. And then I would like, when I would do this stuff, I would ask myself, does that number make any sense? And I'm like, yeah. Because this says like 2.1% of the people, right, have the disease, right? 94.6% of those people also tested positive. Is that correct? So the people who are both positive and have the disease should be a little less than 21%. Is that correct? I mean, excuse me, 2.1%. Is that right? So we get like 0.019, whatever. Does that make sense? It's like 1.98 compared to 2.1. Does that make sense? Right? I'm like, yeah, whatever. 95%. Sure. That sounds right. Does that make sense? All right. So then this garbage. All right. What is this crap now? So then this is 0.979 times 0.033. All right. So that's 0.032307. 0.032307. I think I gotta fix this pen. 0.32307, right? Is that what they said? 32307. Okay. So this thing, does this garbage make any sense? Well, 97.9% of the population doesn't have the disease. Now it's only 3% of those people, though, right? This is almost like 100. Is that correct? So this is like going to be like around 3%, or something like that. Is that correct? So yeah, they got around 3%, whatever. Does that make sense? Should make sense. Question? All right, what'd you get for the number here? 0.052 you got? Is that what you got? Zero 0.52 can't be right. Right? Should be, I think that sounds about right. I'm just waiting for some people to see if this is right. So then we get this number plus, then what was it? 0.021 times 0.946. So then this was on the denominator. So then I just pushed one of these buttons, this thing puts it on the denominator. Then this times this garbage. So that's 0.021 times 0.946. And we get 38,077, whatever. All right? 38.08%. Does that make sense? Any question with this? Question, Joel? All I do is just type this in the calculator, and then I got that. Just remember to always kind of figure out the denominator first. Does that make sense? Because there's really parentheses really here and here. And that's where people make, honestly, a lot of mistakes also typing in the calculator. Does that make sense? Because if you just do this divided by this plus that, like it's not going to give you the right answer. Does that make sense? You have to do this divided by parentheses. This. Is that right? Yeah. Right. Well, that's what we calculated. Does that make sense? Now, again, this should be easy what I'm about to say. 0.021 times the people go down this road and they have the disease. Then 0.979 times people don't have the disease. When people have the disease, they end up testing either positive or they don't. When people, they either test positive or they don't. So then the people test positive is 94.6. This is what, 0.54. This is 3.3%. This is 3.3 is 96.7, whatever. Does that make sense? Does that make sense? There's a 94.6% chance you turn this way, there's a 5.4% chance you turn that way. Is that right? So then positives. Okay, these people are positive. These people are positive. Is that right? So then, like, well, how many people here are there? Well, okay, well, 0.021 times 0.946. Is that correct? 94.6% of the time you will turn left. Is that right? If you went this way. Does that make sense? So then you get this. Then this one's going to be what? 0.979 times 0.033. So then the answer has to be this one divided by this one plus this one. Does that make sense? Because this is the total positive, and these are the people that are diseased and positive. Is that correct? So it's this number divided by this number plus this number. Does that make sense? Does that make sense, guys? I don't know. I like this diagram when I was a kid. I would always do this diagram. But it's the same thing as really drawing the 4 boxes. It's not really any different. Does that make sense? Question? Anybody? Joel, does that make sense? Any question? I feel like when I start saying you turn this way 94% of the time, it's like, I don't know. That means given though. Does that make sense? But again, the thing that's important is just to remember which one's given and which one's and. That's the easiest part to make a mistake with, honestly. Okay. And this is the whole point of the question, honest, in my opinion, or learning this is to make sure that you can see the difference with those things. Does that make sense? Question? Anybody? All right. In one method of procedure called acceptance sampling, a sample of items is randomly selected without replacement and the entire batch is accepted if every item in the sample is okay. Among 810 value scales, 102 are defective. If 4 of the scales are randomly selected and tested, what's the probability the entire batch will be accepted? Is this scheme likely to detect a large number of defects? If 4 of the scales are randomly selected and tested, what's the probability that the entire batch will be accepted? Probability that the batch is accepted given, or if we have 4 of these things. All right. Sample is randomly selected without replacement. The entire batch is accepted if every item in the sample is okay. Okay, so that really just means now the only way it's going to be accepted is the first one has to be good, and the second one has to be good, and the third one has to be good, and the fourth one has to be good. So then it's like there's 4 slots. 1, 2, 3, 4. What's the probability the first one will be good? What will we say? Sorry? But you get 50%. You just what, automatically half of them are automatically good? That'd be kind of bad if you went to the airport and half the scales worked. How do you get that? Nope. Not reading. You do that stuff though, you're gonna get it wrong. And I'm not saying this stuff about like the final and stuff like that to scare people. I just know people have trouble with this stuff. Does that make sense? This is not easy. Okay? So when people start telling me, oh yeah, it's easy, I know how to do it. Yeah, all right. That means you didn't do the homework. Does that make sense? How do you get that? No, you didn't. Well, she didn't get 87, so
Yeah, well,
she didn't get 87.
then I the number is 10, and then I go, and I just subtracted that. Just open six. So
That's correct, but you're making it too confusing for yourself. All right? Yeah, you're making it, you're doing it too crazy. All right, so this thing here, right? All right, so you said it more or less right. It's just you don't have to do all this like multiplying by 100 and all this kind of stuff. All right, so like the probability that they're going to be good, right? For the first one, right? Is going to be what? The chances that it's actually good. So I just like doing number divided by total. Okay. So then the number is going to be what? 810 minus 102 are good. Is that correct? Over 810. Now, what you were saying is the probability that's going to be good is 1 minus the probability that it's going to be not good, which is fine. 1 minus the probability it's not good, though, is 102 out of 810. Does that make sense? So all I was saying is that if you wanted to just say what this was, you might as well just do 810 minus the 102. Does that make sense? Start saying how many there would be. Does that make sense? If you're going to do it this way, then do 102 minus 810, take that all away from 1. Does that make sense? You don't have to multiply by 100 and stuff. Does that make sense? All right. So then but this way to me is like the simplest way, right? Because all I was asking you is really what do you put on the top and what do you put on the bottom? That's all I'm really ever asking. Always try that first. Does that make sense? So then this is going to be 700 and what? 8, I guess, right? Over 810. Is that correct? Right? And then whatever this number is. Does that make sense? All right. How are we going to use that here? What's the chances the first one's going to be good, right? Again, try and always just write the total. So like the total for the first one is what? There's 810 scales. Is that correct? What's the chances that first one would be good if we randomly picked a scale, right? 708 of them out of the 810. Is that correct? Well, you tell me, would it? You tell me.
that's why.
Well, what do you mean? How? Based off what in the question? Because the thing is like I don't like this. Like what you're doing is you're just trying to remember stuff that we've done before and then try to apply it. But if you just take it one more step and read the question while you're doing that same thing, you'll get all of them right. Does that make sense? You can't just guess what to do. What do you mean no? Seriously, what do you mean no? Like you can't just guess what to do and assume it's whatever we were doing before. Does that make sense?
I mean, I think this is like what kind of
Why? How? Explain why. I don't understand.
because there's 7.
Yeah, but what about what does it mean about the next one? Like, what does that have to do with the next thing? Like, that's what I'm trying to say. Like, you haven't explained anything about the next thing whatsoever.
One's already right, and it's just like one less chance of the next.
Why?
Like, let's say like this example, space box is 708 out of like there's 810 possibilities and 708.
Yeah, but why are we not allowed to go and do it again? Like, you have to tell me something based off the question. You can't just start saying, oh, sample space and all this stuff like that. It has to be based off of what the information that's given to you, because sometimes you're not going to be able to do this. Like, you can't just say every time it's going to be like that. Go ahead. Because the sample is selected without replacement is correct. Because it says right here in the question, without replacement. Now, honestly, even if it didn't say without replacement, I'd be like, yo, you're an idiot if you did this with replacement. Because the thing is like in real life, I'm talking about. Does that make sense what I'm saying? Like because if the person, so let's say what's actually try and think about what they're trying to do. Does that make sense what I'm saying? So they're in some sort of airport or whatever, right? And they have these baggage scales, and you know what the baggage scales are for, right? They're trying to charge her ass. Is that correct? Right? Especially if you go on these international trips. Does that make sense? Like they go and charge, okay? It's expensive. All right. So the thing is like, and you want to go away somewhere for a long time, you got to bring a lot of luggage. Like you got some serious problems. Does that make sense? It's gonna cost you money. All right. So these people, they need these scales to work, correct? Also, people try and bring in drugs and all this stuff, right? These scales are the only things that are really helping them to figure out what's going on. Does that make sense? Because people weigh it and then they take something and put it in there and then you weigh it again, then you can see what happened. Does that make sense? All right. So one of the ways, obviously. All right. So then these things, if you're going to go and try and test the scales to see how well they're working, right? You go grab a bunch of the scales. Is that correct? And then again, we want these stupid things to work. Is that correct? Right? So like you'd grab a bunch of the scales and then you would test those scales that you just grabbed. You sample them. Is that right? So that's what they're doing. They're sitting here and they're getting 4. Does that make sense? And then they're asking us if they grab these 4 scales, is it actually going to work out? Will these people actually be able to figure out if there's actually a problem? Does that make sense? So then he says to accept the sample, all of the samples or the things in the sample have to be working, which makes sense. We want them to work. Is that correct? But you wouldn't pick the same scale 4 times in a row. Is that right? That makes no sense. Does that understand what I'm saying? You would grab 4 different scales. Does that understand what I'm saying? So even if he didn't say this in this case, you would be expected to be able to say that. Does that make sense? Based off of what they're describing in the question. Does everybody understand what I'm saying about that? Okay, but yes, we need to ask ourselves when we're doing that, is this with replacement or is this without replacement? That's exactly correct. Does that make sense what I'm saying? And then it is, you were doing it right. If you drew a scale out of the thing, you're putting it back in so that correct. But if they tell me that you're grabbing 4 scales from a bunch of scales in New York, whatever, there's no way the person's going to sit there and grab the same one, right? You know what I mean? What's the chances you pass the test? Oh, I'm going to grab you 4 times? No, I'm going to ask everybody. And then I'm going to grab one person. I'm going to grab another person. You know what I mean? Does that make sense? So I can get information about everything. Does that make sense? So you would never do this with replacement. It doesn't even, there's no reason. Does that make sense? So so you're correct. This number, but I'm just trying to say, all you got to do is ask yourself that question. Can we put the thing back? Right? Can it be replaced? And that's it. But you're right. You have to think about the samples. So 706 over 806, whatever, 705 over 805. Okay, whatever. All right. I'm sure you can multiply this in your calculator. Among the contestants in a competition, 47 are women, 20 are men. If 5 winners are randomly selected, find the probability they are all men. Probability all men. What would you say? How would I do this one here? Should be kind of easy after the last one. Now, this question is not honestly 100% clear. But I think they want you to read it and then make your own decision. And there is one more correct decision, I guess. How do we do it? Come on. What do I do? If they can't win twice is correct, yep. But how many slots do we need though? 5 is correct. So probably that they're all men means man on the first one and man on the second one and man on the last one. So that means there's 5 slots. What's the chances the first person's a man? 20 out of 67. Then it's 19 out of 66. And it's 18 out of 65, 17 out of 64, 16 out of 63. Does that make sense? You just multiply it. Does that make sense, guys? Does it or not? Melanie? There are 12 members on a board of directors. If they elect a chairperson, a secretary, and a treasurer, how many different slates of candidates are possible? Arrangements and groups. That's correct. So which one is this? Groups or arrangements? Good. Arrangements. But when we do arrangements, we don't even need the stupid formula. Is that correct? Right. So how many slots do we need? 3. What do I write in the first one? What'd you say? No. 12, because they're not doing probability or anything like that. And I don't know where you got 4 from. But there's 12 people we can select for the chairperson. Is that correct? Then what do we do? 11 for the secretary is correct. And 10 for the treasurer. Does that make sense? Let me just multiply that out. Does that make sense? What about this? This one's the combinations. 12C4. Does that make sense? Because they say committees. There's no order in this. So that's 12 factorial over 8 factorial, 4 factorial, which is 12, 11, 10, 9, 4, 3, 2, 1. So whatever that is, 55 times 9, 99 times 5. 475. Does that make sense? No, 495. Question? 1.8% of people are infected with a disease. There is a test for the disease. However, the test is not completely accurate. 91.7% of those people have the disease, test positive. 4.8% of people do not have the disease, test positive. Person randomly selected for test for the disease. What is probably the person has the disease given they were positive? So this is the positives are 1.8 out of those people. 91.7% are positive. Then the other group would be 98.2 and 4.8% of those people. So we get this. That makes sense? The one we were just doing before. Yeah. Yeah. Does that make sense? But I'm trying to do it faster now because I'm not trying to write all that stuff out because I'm just trying to show you just what you need to actually do to get the question. Because like honestly, when I was taking the test, when I was doing my homework, I'll write the stuff out so I can try to understand what it was. But I'm not doing that when I'm taking the test. Does that make sense? I'm just trying to answer the question. Does that make sense? All right. Yes, sir. So these are like the chances that they are positive, and then this right here is the chances that they are diseased and positive. This is diseased and positive. This is not diseased and positive. 982. All I'm doing is like this right here is the people that have the disease, right? So either you have the disease and you test positive, right? Or you don't have the disease and you test positive. How are you going to figure out the people that don't have the disease? If 1.8% of the people, right? So that's like 1.8 cents. Does that make sense? So if I have $1 and I take away 1.8 cents, that means I have 98.2 cents. Does that make sense what I'm saying? That's all I'm doing. Okay. But that's the part that sometimes becomes the most annoying thing because you forget to do it. Right? That was the thing I was saying that the author was acting like a jerk about. Okay. Because here they tell me how many people have the disease. They're not going to always tell you how many people don't have the disease because they expect you to be able to say it. Does that make sense? Does that make sense? But you got to remember to do that. It's easy to make a mistake or not see that. Okay. All right. Question. All right. Let's start the next chapter. All right. So then, Capitulio Cinco. All right. So I think this one is called, I don't know what this is called, but it's about discrete probability distributions and random variables. All right. All right. So the first thing they want us to talk about is, I guess, well, what is a random variable? I think we've already said this though. Did I talk about this already? What's deterministic and what's random? I think we talked about it like the first day. But uh, everything in math starts seemingly becomes self-explanatory after you know it, but then it's just not at all in reality. All right. And then it's still there's more crap to it always. So random variable. This is a variable that can be determined only by chance. And this is a variable that can be measured or is not random. So like I cannot determine the number of heads when flipping a coin 5 times without actually flipping it. Does that make sense? I can tell you the chances you're going to get 3 heads. I can tell you the chances you're going to get 4 heads. I can tell you the chances you're going to get 2 heads. But I cannot tell you how many heads you're going to get. Does that make sense? Right? If I sit here and I say to you, how many cars do you have at your house? Like it ain't changing. Does that make sense? It might change here or there, but for the most part, it's just like it is what it is. And then even if it is going to change, you're going to change it. Does that make sense what I'm saying? The heads and tails, like you're not, you sort of are changing it, but like you don't even know how you're changing. Does that make sense? When you flip the coin. Is that correct? It's random, we're calling it. Does that make sense? All right. So then random variables are broken up into more cases than what I'm about to say, but they want to discuss what a discrete random variable is and what a continuous random variable is. And we've already sort of discussed this already also. This should have was actually on your homework. What you remember what this means? No. That's not the right that's not the right discrete. It's spelled differently. Mm-mm. Sort of. Yeah. Ah, no. Um So a discrete random variable was a variable that can take on values or let's say the possible values have numerical gaps between each possibility. I'll explain more in a second. Continuous random variable is the possible values occur over an interval. Does anyone remember what interval means? Should know this from math. So it's like we would write these things with like these parentheses or something like this. Does that make sense? Or you write these brackets or whatever. Is that correct? Does that make sense? But all this means is, okay, this crap is important. Because this is the reason why is not because of stupid math, to be honest. It's because, well, I mean, it is important in math also, but it's kind of simple, the math part. I can explain it to anybody in 2 seconds. Like, that's not really the hard part. All right. But the thing is that you are hard. None of it's hard, this part, actually. All right. But the thing is you have to be able to type things into computers. Does that make sense? And quite often, this type of notation is used for how you type the thing into the computer. So that's why you really need to know it. Does that make sense? All right. So the this thing's like, what does these intervals mean? So like I don't know. Like they'll sit there and be like, x is less than or equal to 3 is less than 7 or something. And then they'll write it like this. Where the bracket means it could equal to it, and then the parentheses means it can't equal to it. Does that make sense? No, this is less than 7, and greater than or equal to 3. Does that make sense? This is between 3 and 7. Could be 3. Does that make sense? All right. X is bigger than this 3. Does that make sense?
It could be that number.
Or less. More or less. So then like this, in this case here, it needs to be less than 7. Does that make sense? Right? You understand? But this means between 3 and 7, but could be 3. Does that make sense? But not 7. Okay. Anyway, it's called an interval. Does that make sense? All that means though is that you have a number line. I don't actually like writing it with these things because I don't think it makes any sense, to be honest. I don't know why they do this in these stupid books now. But like when I was younger, they used to write it like this. At the 7, you can't go there, but the 3, we can go there. Does that make sense? So we get all this crap. Does that make sense? Right? And all those things are possible or solutions or whatever. Does that make sense? All right. So then they're now asking us something about this discrete versus continuous. And I said that these things have like these gaps between the numbers, and these things are intervals or like an entire range of values. Does that make sense? Does that make sense? All right. So then the next question they start asking is can you tell me a random variable that would be discrete or that would be continuous? Can you give me an example of something random, right? Where the outcome of that variable would have these gaps between the possibilities. Or give me a continuous random variable where the outcome would be really any number in some range of values. Could be anything over a particular interval. Does that make sense? Dice roll in what sense? The outcome on the dice? Yeah. So then the let's say the outcome on one roll of die. Does that make sense? Why? What are the possible outcomes? Could be 1, 2, 3, 4, 5, 6. But like if I go and write that out, like day some gaps between these possibilities. Like you ain't getting 5.5 on this die. The only thing we can get are just those numbers, not all the stuff in between. Does that make sense? Does that make sense? Discrete. Does that make sense? Continuous follows a continuum of values. Does that make sense? Discretized usually means making things into like chopping it up. So there's like a finite number of them. Does that make sense? Because I can't do shit with stuff when there's not a finite number of them. You can't add up an infinite number of things. Well, you sort of can, but it gets more confusing. Okay, but the most of the time, the only thing anybody ever wants to do is add up finite things. Does that make sense? All right. So all right. So what's an example of something that would be continuous then? In other words, that the outcomes would occur over a range of values or over an interval. So let's just say that the possible values occur over an interval, let's say, or a range of values. Right? So something that's random. Coin the probability. The problem is with coins is that like, how the hell am I going to get something like 1.5? Do you get what I'm saying? Pretty much most things about a coin would end up being discrete, but like it depends on what you ask me. There's always a way to make it not. But go ahead. All right, like if we go to some forest or something like that, and then we start randomly picking an animal out of that forest and weighing the thing, yeah, I would agree with that. Does that make sense? The weight of whatever. Does that make sense? Sorry? The weight of a die? What do you mean a die? Yeah. But he's saying you randomly were to select some sort of animal and then we were to weigh it, then that weight, I mean, it doesn't even need to be an animal, it could be a person. Does that make sense? Right? But then these things would like, I don't know what the person would weigh, but there would be some minimum thing that the person could weigh, there'd be some maximum thing the person could weigh, and then really anything between that would be possible. Is that correct? Does that make sense? Something interesting to think about though, if I say your measured weight, that becomes discrete again. Does that make sense? Because if I measure your weight, when I put you on the scale, it doesn't actually give me all the decimal points for forever. Does that make sense? Stop somewhere. Is that correct? You're 10.2547 pounds or whatever. But in reality, there's more decimals. Is that correct? Well, we can't even measure it. It's too small. Does that make sense? Does that make sense? Eventually, it becomes too small. Mm-hmm. Yeah, the point is not the brackets. Those are just the endpoints. Does that make sense? Like, if there's no bracket whatsoever, it's just this. It's the fact that all of these things are possible. That's the continuous part. Does that make sense? All right. The interval doesn't really matter. Interval is just a name that's like a collection of things that are like connected to each other. Does that make sense? You have everything next to each other. Does that make sense? So that is not a random variable the way you're describing it. Okay. So if we said we were on a road, okay, and we were outside of Broward College, okay, and we monitored all of the students and we determined that they were driving between 45 and 55 miles per hour, and then we randomly selected a student that was driving to Broward College. What was the speed that particular individual was traveling at, right outside, right? Then the answer would be somewhere between 45 and 55. But you have to make sure you define it properly. Otherwise, it's not even random. Does that make sense what I'm saying? Like what you're stating to me is just like a fact. Does that make sense? That's not a variable necessarily. Does that make sense? All right. But I get what you're not like wrong also. Does that make sense what I'm saying? Yeah, I get what you're trying to say. Otherwise, I wouldn't be saying what I was saying. But yes, okay. But if I said like you know, you're gonna go play football, let's say, all right, or whatever, and you're playing this game tomorrow and you're on this team or something like that. And then I start asking you, like, you know, the number of touchdowns you will score tomorrow. I mean, that's certainly random to some extent. Does that make sense what I'm saying? You get injured at the beginning, whatever, you play against a good team, play against a bad team, you know, whatever. Does that make sense? It rains, it doesn't rain, bad quarterback, good quarterback, whatever. Does that make sense what I'm saying? All right. This. Does everybody see that? Another one here that people usually think of is like height, something with time. Does that make sense? Does that make sense? All right. Question with that so far? You understand what they're trying to say? Classification of these variables. All right. All right. All right. Let's see what they ask us here. The height of a randomly selected student, discrete or continuous? Continuous. Now, though, if I was trying to be a jerk and I started saying the measured height, though, it would be discrete. Does that make sense? Because you're either a meter and a centimeter, a meter and 2 centimeters, a meter and 3 centimeters, etc. Does that make sense? Like you even ask people when they start saying their height, right? What's your height? Oh, I'm about 6 feet tall. I'm about 6'1". I'm about 5'8", right? They don't sit there and start telling you they're 5'8", 0.43754748213, whatever. Does that make sense? Like you'd be like, yo, shut up. I don't care. Like you're 5'8". I got you. Right. So like you get what I'm saying? The number of phone calls between New York and California on Thanksgiving Day. Discrete, because you ain't getting 3.5 phone calls. Is that correct? I don't even know what that means. Does that make sense? Okay. This sounds like it's going to be tough, but honestly, whoa. We been doing stuff like this the whole time, so this really isn't going to be very different than some of the stuff we've already done. This thing from the first chapter. So probability distribution. All that means is you list the x's over here, and then you list the probabilities over there. So this is the first possible event, the probability of that event. Second possible event, probability of that event. And then all the different events and their respective probabilities. So what is a probability distribution? It is a set of disjoint events that and their, well, a set of disjoint events that partition the sample space and their respective probabilities. There's some rules to this thing. The first one is that the probability of any single event is going to be between 0 and 1. Second thing is that the sum of all of the probabilities must equal to what? 1. And then in this book, it says this, but this isn't really like 100% really a rule, but your book's going to say this, so I want you to go with it because that's how you answer your questions. Does that make sense? So this says that the x's or the values, right? We called these the values before, and those were like the frequencies, the other things. Is that correct? The values need to be numerical. Okay? They need to be numbers. Does that make sense? All right, what does this mean? Does anybody know what this word means? Partition? You know what that word means in English? It means like separating something out. Does that make sense? So like the states, but not just a separation. It means a particular type of separation also. Okay. So like the states of the United States are called a partition. Does that make sense? No state overlaps with any other state. Does that make sense? And then no matter where you are in the United States, you're in one of those things. Okay, that's called a partition. So what do I mean by that? Like if I take this thing and I want to make a partition, right? I make a bunch of sets where each of the sets and the other sets don't intersect. So like I make a set here, make a set there, make a set there, whatever this is. Keep doing all of this. And then the union of all of these sets is equal to the entire sample space. So in other words, just break the stupid thing up into a bunch of parts, but then the parts don't overlap. Does that make sense? You got to have the whole thing. Does that make sense? So then if I say the probability of this plus the probability of this, but probably all this stuff is going to be 1. Is that correct? It's everything. Is that right? Does that make sense? All right. So then each probability of each individual thing here would have to be between 0 and 1. The sum of all these probabilities, in other words, the sum of all of this right here, would have to be 1. These values here are supposed to be numbers. Does that make sense? Does that make sense? All right. Determine whether the following is probability distribution. If not, identify the requirement that's not satisfied. If a person is randomly selected from a certain town, the probability distribution for the number of X siblings, the number X of siblings, excuse me, is as described in the following table. What would you say? Is this a probability distribution or not? Why or why not? Why would you say no? Nope. 0 is a number, so that's okay. That's correct. This is what? 4, 6, 7, 14, 18, right? That ends in 8. That's no good. We're already done. 1, this is 3, 6, 8, 9. We have 98%. That's not right. That can't be a probability distribution. That's not everything. Does that make sense? What's missing? Based off what they described in the question, what's missing here? Why did we only get 98? Based off what they're describing here, what they're doing the siblings, yeah. But what I'm saying is like what based off what they've provided us here in terms of the information, why is it not everything? What's missing? How many siblings you guys got? How many siblings you guys got? How many you got? 2. What about you? 2. What about you? 2. 1. Sorry. 1. 4. 4. 2. I mean, but like anybody got more than 5? Could you though? My neighbors, they were Mormons. They make babies, these people. Okay. So like they had like, I don't remember, 15 kids or something like that. Yeah, it was a big ass house, bro. All right. So like they had like 15 kids. Yeah, daughter, she was hot. Anyway, but they had 15 kids, okay? And like, I mean, I was surprised. Like I thought there was like 7 or 8. I was like, damn. No, they just kept coming out. I was like, all right, No, but the problem is that like, go ahead. Correct. 6 or more, right? Right. So it should say like 6 or more here, and then that would be 0.02. Now we would be fine. Does that make sense? But I'm just trying to say, like, based off this, like, why would we only have 5 necessarily? Based off the numbers you provided, you obviously are just not counting these people. Some people have more than 5. Is that correct? Maybe. I mean, I don't, but you know, them Mormons, they did. All right. Those people were actually really nice. Well, that's the thing that they say that we're supposed to know from previous based off of, you know, the chances, right, of each of the things, right? So if I say, you know, like, what's the chances you're a shitty Marlins fan, right? No, I'm just kidding. But like, there's all these different sports teams, right? And these people are either fans of the Marlins, or they're fans of this one, 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 right? So if you talk about all the sports fans, let's say for baseball, right? Then either they like the Yankees, they like the Mets, they like the Phillies, they like the Marlins, they like whoever, right? And then if we took all of those people and we're like, oh, 5% of the people like the Marlins, let's say. There's probably less than that, but let's say it's 5%. Okay. So like I'm pissed about the Marlins ever since they beat the Yankees a long time ago. So like I stopped watching baseball for a bit actually. But the 5%, let's say like the Marlins. Let's say 6% like this one. When you add up all of these things, it better add up to 100, or that means you haven't counted people. Does that make sense? All right. All right, let's just finish these next two. I think it's easy. Or just actually just this one. Well, yeah, we'll talk about the next one a little bit also. What's this one? The accompanying table shows the probability distribution X for the number of shows up with a loaded die or whatever. Oh, wait, I can't. That's not the right question. All right, we done. That's going to take a little while to talk about. We should wait. I thought there were more examples with some probability distribution stuff.